Hello. Today we're going to talk about the conditions for unique triangle, and what they mean by unique triangle is you can have two triangles that are congruent, but that would imply one is just the same as the other. And so what unique is, it would have some difference between it and another triangle. And so what we're going to focus on are the possibilities of having unique triangles when we have three given sides or two sides and an included angle. And so just as a reminder on how we even build a triangle with a compass and straight edge given a three side lengths, you first start with your straight edge, you draw your line, you get the distance from point to point, and you mark. And so what this represents is Z here and X there. And then you go back and forth. You put your needle on Z, go to Y, so Z and Y, and then X and Y. Unfortunately, I didn't make that long enough, so I have to go back and start again. And so this is my point Y where they intersect, and then I just draw the line segments. And that's how I construct a triangle. Now, what we really ultimately want to do is decide if this is going to be a unique triangle compared to, say, if we were given our shoulder partner's work. And so what I'm going to do is I'm going to use transparencies and see if we can find a different triangle. So there's the red. Here's Y and Z. And if you've done this before, you might have used like straws or popsicle sticks that were cut. And basically what I want to try and do is I want to try and arrange these so that I get a triangle that is different than the one I just drew. And so you can see that starting off there are some subtle differences with orientation, but the question is, will that end up being, if I were to transform it, will that end up being an actually different triangle? And so I see this, and then I just put it over top of it. Oop, moved a little bit. And what you're going to notice is that it didn't end up mattering. And so it won't matter if I reflect it or rotated it. These three lengths, if I'm given three lengths, it defines a single triangle, and so it doesn't matter if it's oriented one way or another, if it's flipped, if it's been rotated. Essentially what would happen is I'd be able to come back to this triangle. And so that's an important result, that when you're given three sides, you are actually constructing a very unique triangle. And so you come by it in a different problem, and it says triangle ABC is located below. Copy the size of the triangle to create ABC. Use your compass to determine. And so this is a little bit different. The side lengths weren't given to you, but you can start anywhere with this. And so I start here. I'm going to go from B to A. So here's B. That's where I'm going to mark my A. And then I'll mark off from B to C. And then from A to C. So I didn't make it quite long enough once again. But we can go back and make sure that that lines up. And so this would be my point C. And so the question really becomes, are these identical triangles? And one way you could start off with is we know that if we want congruent triangles, we have to have the same exact measures. And so if I put this on here from 0, and it looks like this is approximately 4.7 centimeters, and then I come down here, and this is approximately 4.7 centimeters. So we're off to a good start. And you'd go through this and you would compare the side lengths to determine whether they were congruent or not. And that's just about 2.4. I didn't quite make that point out there. And this one appears to be 3.7 centimeters, and then we come down here and we realize this is also just about 3.7 centimeters. So that's the good first start. The next thing you might want to do is measure some angles. And so I can see that measure of angle B is approximately 50 degrees. If I come down here, I look at this, the measure of angle B is approximately also 50 degrees. And so what you're seeing is that you end up with all three angles congruent and all three sides congruent, meaning that we do not have a different triangle at all. We actually have one that will lie directly on top. And so what your summary is a unique triangle can be defined by three congruent corresponding sides. Okay, so that's sort of your big takeaway on that. So then you might begin wondering, well, can I limit the number of sides and angles that I am looking at in a different way? Because if three sides worked, is it maybe that I could do two sides and an angle? And so what we have here in this scenario is triangle DEF isn't quite created yet. And ordinarily you'd be doing this with your MESA group, but they want a 40-degree angle, and they want a 7-centimeter side, and they want a 4-centimeter side. And so this would define my triangle. Okay. They want us to construct another triangle with the same criteria. First thing is that we need to construct that 40-degree angle. And so we start off with our compass. I have the baseline here. I create the 40-degree angle. And then I need a 4-centimeter side. So I'm going to use my compass. There's 7 centimeters and a 4 centimeters. So it looks like this. And so on the 40-degree angle, those mark the distances that were required. And I draw that connecting. And so now the question is this triangle the same as that triangle? Well, we already know that this is 7 centimeters. We know that this is 4 centimeters. And we just sort of systematically proved that if we have 3 sides, we'll have unique triangles. So if I can get this third side here, which is approximately 4.8 centimeters. And I look at this side over here, and I'll get approximately 4.8 centimeters also. You're going to see that you have 3 congruent sides with at least one angle. And so maybe you're someone who wants to just be very thorough, and you check this out, and you see that this angle is approximately 105 degrees, and you go make the same comparison over here. And you'll see that the angle is approximately, again, just a little bit off, but approximately 106 degrees. So there's a little human error. But you've got congruent angles, you've got 3 congruent sides. And so, in short, in summary, if you are given 2 congruent corresponding sides and the included, and so this is the really important word, included angle, the triangles will be congruent. And so, in other words, this is a unique setup. Even though you have 2 different triangles, there's only one, in reality, one triangle with these specific measurements. Okay? So in summary, here you go. The lesson summary is the following conditions determine a unique triangle: 3 sides and 2 sides and included angle. Thank you for your time.